Good morning to my dear students, and also welcome to electronics online classes. Look here in the yesterday's class, you have started the new topic, and as I said, it's so important topic, and also it is having interesting topic, important and interesting topic. That is, has been about operational amplifier. The topic name is about operational amplifier, and in the yesterday's class we are discussing about what is op amp and why it is called op amp and what are the advantages of op amp and also what are the applications of op amp. Also you have studied about the block diagram of op amp. And today we'll discuss about in detail about that operational amplifier. Especially in your today's class, and today we are going for the lecture number 2. We are going for the lecture number 2. Look here in the lecture number 2, we are studying about the, as I said already, they basically your operational amplifier. It is a type of differential amplifier. Basically, the operational amplifier, basically it is a differential amplifier. And as I said already, today we discuss about in detail about the differential amplifier and what is differential amplifier and what are the types of differential amplifier. And also we go for in detail about the working of the differential amplifier. And before going for the today's class, once again we recall what was studied in the yesterday's class. As we know already, the op amp or operational amplifier, we write about op amp. In short term, we write about op amp. Is it is so important, versatile analog integrated circuit. It is so important and versatile analog integrated circuit. And because of it is constructed by using the integrated circuit, or in, as I said, in the before 1946, they are constructing op amp by using the vacuum tubes, and because of vacuum tubes are very bulky and they require more power, that's why. And in 1963 the first integrated monolithic first integrated circuit were developed, and what you are using nowadays, and also according to syllabus you are using about IC 741. The IC, this is invented in the 1968. In the 1968, they are developed or invented the IC 741. It is so famous, and also important thing about this IC 741, it is constructed by using the IC technology. They are using the integrated circuit technology. The op amp, the IC 741 is constructed by the technique of your integrated circuit technology. And as I said already, why you are giving more importance to the op amp? Because of its having the very compact in size, lightweight, and it requires very less power consumption, and is having the most important thing about it is so reliable, and it is having very less distortion, less noise, and these are the advantages of why we prefer the operational amplifier. And as I said already, what is called op amp? It is a directly coupled high gain differential amplifier. I am saying in simple way. What is op amp? It is a directly coupled high gain differential amplifier. It is in simple way of the definition. If we go on another way of definition, same The op-amp is a directly coupled high gain, high input impedance, low output impedance and negative feedback differential amplifier. And I said here, why we are giving more importance to the operational amplifier? Because the amplifier it not only amplifies signal. Why it is called operational? Why it is called operational? Operational amplifier. Why it is called operational? Because the not only it amplifies the signals, it also do the operation. What operation? It will do the mathematical operation, such as said about in yesterday's class, the addition, subtraction, and so many subtraction, multiplication, differentiation, integration, and also can possible to go further. It acts as a logarithmic and anti-logarithmic amplifier. These that's why it is called operation. It will do the such operations, mathematical operations, addition, subtraction, multiplication, and integration, differentiation, logarithmic, anti-logarithmic. Also, you can go for scale changing, and it is also called as sign changer. It is also called as averager. These are the important operation the op-amp will do. That's what is called as operation amplifier. And as I said yesterday's class, so many students will confuse what is op-amp and why it is called op-amp. If the question may ask what is op-amp, but so many students will give the answer. It will do the mathematical operations such as addition, subtraction, multiplication, integration, differentiation. It is not correct answer. The answer is why it is called op-amp means it will do the mathematical operations such as addition, subtraction, multiplication, difference, integration. And what is called op-amp? It is a directly coupled high gain and high input impedance, low output impedance and negative feedback amplifier. This is about your why it is called op-amp and what is called op-amp. And I just said what are the applications where you are using your op-amp, because I just said it will do the multitask. It will do the multitask, and it is called the versatile device. It is so called versatile device. It means what it will do. Yesterday I said discussed in detail. It is used for your in instrumentation control as an voltage regulator, and in your oscillator it is used for the phase shift, and also it is for in your comparator or in your A to D converter or D to A converter, or it is used for your in the active filters. It is also used for a square wave generator or a triangular wave generator or pulse generator. And yesterday I said very good thing. You can convert the voltage into current and current into voltage. These are the important applications of your op-amp. That's why we prefer more about the op-amp. And another important thing, what is the difference about operational amplifier and amplifier? What is the difference about the only amplifier and operational amplifier? What is the difference about only op-amp and amplifier? As we know, in amplifier, you are having only one input, one output. In amplifier, having only input, one output. But here, in op-amp, you are having two inputs. Output being one or two, but you are having the two inputs. In op-amp, having the two inputs, but in amplifier, having only one input. And also, in your op-amp, you can not only amplify signal, also you can go for the addition, subtraction, multiplication and difference integration. That is not possible in your amplifier. Amplifier only amplifies signal. It will should not do the addition, subtraction, multiplication, differentiation and integration. That's why we prefer op-amp rather than your operational amplifier. Rather than your in general amplifier. No doubt it is also amplifier. This is also amplifier, but it is having more advantages because it will do the mathematical operation. It is not doing the mathematical, only it will amplify the signal. Whatever apply the signal, it will current or voltage, that will amplify. And also in op-amp there are two inputs, but here I have only one input, one output. This is about the major difference of op-amp and amplifier. And also, as I said in the yesterday's class, in op-amp it will combine both the features. It is having the feature of single stage amplifier, it is also the feature of having the multi-stage amplifier. What the single stage amplifier do and what the multi-stage amplifier do, both the things done by your operation amplifier. Both the things done by the operation amplifier. And also yesterday I said about your op-amp is called perfect amplifier. The op-amp is called perfect amplifier. Why it is called perfect amplifier? Because yesterday I said, in general, you consider any amplifier, we are giving more importance to the 5 to 6 their parameters or their characteristics. And always we want, yesterday I said about, we want the more voltage gain. Always it may be any amplifier, we want the more voltage gain. More voltage gain. More voltage gain. And also we want more input impedance. We want more input impedance. We want more input impedance. Also we want very less output impedance. And also we want very low or less distortion. And also we want very less noise. And also it is having the more bandwidth. The 6 parameter, it will give the more bandwidth. These are the important parameters of amplifier. These all parameters are satisfied by our op-amp. In general, we want more voltage gain, that is given by our op-amp. It's basically op-amp is a voltage amplifier. It is a voltage amplifier, and it will give the more voltage gain, and it also gives the more input impedance. It will give the very less output impedance, and it will give the very less distortion. And most important, we are having very less noise, and we are having more bandwidth. That's why the operation amplifier is called as perfect amplifier. It is an ideal amplifier. You can say it is an ideal amplifier. This is the importance of your operation amplifier. And also yesterday I said about in the op-amp, it is used for by using the op-amp you can construct the linear electronic circuits. Also you can construct the non-linear electronic circuits. By using the op-amp you can construct linear circuits as well as non-linear circuits. That also importance of your op-amp. And yesterday I said by using op-amp you can amplify AC as well as DC signals. You can amplify AC as well as DC signals. And basically in your op-amp it consists of a transistor and resistor, capacitor and diodes. While you can externally add a resistor, capacitor and diodes in the input output, we can change the characteristic of the op-amp, or you can change the parameters of the op-amp. While connecting the capacitor or your resistor and diode in the input or output, we can change the parameters of your operation amplifier. That is the importance of your op-amp. And also in the last class you studied about the block diagram. You studied about the block diagram. That is, it is having the 4 important input stage. I studied already, not going in detail. And it is having the gain stage, and it is having the level changer or level shifter, and finally having the output stage. As I said yesterday in class, discussed it in detail already. I'm not going in detail. Especially in the graph diagram, the first stage is nothing but input stage, and in the input you are using the differential amplifier. In the input stage you are having the differential amplifier, and the differential amplifier having the two inputs and two outputs. It is also called as dual input and balanced output. And what is the use of the input stage? It will give the more voltage again, it will give the more input impedance, also it will reject the noise. This is about importance of your input stage. And here the gain stage, whatever the gain given by the input stage, that is not sufficient. And then the gain stage are using another one type of difference amplifier to increase the further increase the gain. And practically you are using cascade amplifiers. You are using cascaded amplifiers to increase the gain. This is about the gain stage, and you are actually in your first stage and second stage are connected directly. It is called direct coupled because you are not using any coupling device in between the output and input. You are directly coupled, and because of direct coupled, what happens? The input signal, or you can say about the DC level of the output voltage is very low because you are not using capacitors. If you use capacitor, that capacitor blocks the DC, and you are using the direct coupling. You are not using any coupling capacitors or coupling devices. That's why what happens? The DC level is very more, and you should not want more the DC level. You have to reduce the DC level. And how to reduce the DC level? That is by using the level shifter. By using the level shifter, you can shift the level of the DC level, or you can reduce the output voltage to the. You can reduce the DC voltage, or you can reduce the voltage level, ground voltage to the zero. By using level shifter, here the DC will vary more. That DC level can reduce by using your level shifter. That is nothing but you are using an emitter follower or using a common collector amplifier, and it will by using that you can shift the DC level, and also because of the property of your emitter follower common collector amplifier having the more input impedance, that more input impedance will be protected because of the loading effect. Because of the more input impedance, they will protect the device for the loading effect. And finally, you are using about the output stage. That is nothing but you are using about your a push-pull amplifier or complementary push-pull amplifier, or using your class B or can say B push-pull amplifier. And why you are using push-pull amplifier? Because in the output we want more current and more voltage. Also we want very less output impedance. Everything is given by your push-pull amplifier, and this is about in brief about yesterday's class. Now we will go for in detail about this first stage. What is the first stage? The important today's class is about we are discussing about the differential amplifier. We are going for the you are studying about the differential amplifier. Studying about the differential amplifier. Actually, the differential amplifier is a heart of an operational amplifier. The differential amplifier is a heart of an operational amplifier. In every integrated circuits, the first stage is about the differential amplifier. In analog ICs, the first stage is about the differential amplifier. Or in your op amps, in the op amp, always in the op amp, the first stage is about the differential amplifier. And what is called the differential amplifier? As we know the amplifier, it will amplify the signals. And why it is called differential? Because the amplifier will amplify the difference of the two input signals. You follow what I am saying? Why it is called differential amplifier? It is also called as difference amplifier. It is also called as difference amplifier because it will amplify the difference of the two input signals. It will amplify the difference of the two input signals. Or it is called difference amplifier because it is in circuit, it is an amplifier. They will amplify the difference of the two input signals. That's what is called differential amplifier. And as we know, the symbol of your this is the symbol of your differential amplifier. It is having your two inputs V1 and V2. It is having two outputs V01 and V02. It is about the symbol of your differential amplifier, and as I said, it will amplify the difference of the two input signals. As we know, the gain nothing but AD equal to V0 by V. But in this case, what is the gain? The gain is nothing but here the output will be amplified by the difference of the two inputs. You can say about the V0 equal to AD into V1 minus V2. Or you can write about here V0 is directly proportional to the V1 minus V2. You can write the output voltage is directly proportional to the difference of the two input voltage. Or you can this proportion nothing but V0 equal to AD into V1 minus V2. Or you can write about here the AD equal to V0 by, in place of V, you can write V1 minus V2. Or if you want the output voltage is equal to AD into V1 minus V2. It means in the overall the importance of difference amplifier, it will amplify the difference between the two input signals. It will amplify the difference between the two input signals. And I said it may be the two outputs, or it may be the only one output, or it may be the single input, or it may be the dual input. This is about what is difference amplifier and what are the main important function of the difference amplifier. Actually, in your differential amplifier that consists of two transistors. We are having the Q1 and Q2. In your differential amplifier, you are using the two transistors, the Q1 and Q2, and they are in the same. They are on the same configuration. They are using the same. Especially in what common emitter amplifiers, they are using the same type of transistor in the Q1 as well as Q2. They are the same type, and also are using nearly about three resistors. They are using three resistors. Basically, I said to people, why you are preferring the difference amplifier? As I said, you are using the difference amplifier because to avoid the noise, to avoid reduce the noise or reduce the distortions. By using the difference amplifier, you can reduce the noise or you can reduce the distortion. That is about the important function of the difference amplifier. Especially depending upon the input or output, you have done the four types of differential amplifier modes. You are studying about the four important types or modes of your differential amplifier. Next, you go for the types or the different modes, or you can say types of or you can write modes of differential amplifier. Differential amplifier. Actually, they are having nearly the four modes. One is called the dual input and balanced output. And second one, same dual input and unbalanced output. And third one, yes, in the third one, single input and balanced output. And last one, that is the fourth one, single input and unbalanced output. These are the different types of differential amplifier, or you can say different modes of differential amplifier. Actually, here you are using two inputs, and what is called balanced input, you are using the balanced input, you are using two outputs. Unbalanced input, you are using only one output. Two output, two input, two output. That is the type of differential amplifier. In the first mode, dual input means you are having two inputs and two outputs, differential amplifier. In the second case, you are having the two inputs, but you are having only one output. That also one type of differential amplifier. And third one, single input and balanced output. It means single input, the dual output, and here single input and single output. These are the important types of your differential. You will go for one by one. If you draw the diagram, then you can understand how we can give the input and how we will get the output. First, you go for the dual input and balance output. Go for the different types of differential amplifiers. First, you go for the dual input. Go for the first, you go for the dual input and balancing. As I said here, you are using two transistors. They are in the same. They are not same. Yes, you are using two transistors. And here you are using one transistor, and you are using another transistor. You are using another transistor. Look here, as I said, you are using the same type of transistor, the Q1 and Q2. And important thing here, both the emitters are connected together. Both the emitters are connected together. And you can apply the RE in common. You can apply the RE to the common. And as I said here, you are using the dual input and balance output. And in the collector, using the collector resistors is, and you are using RC here. Also, you can apply then positive VCC here. This is RC1 and this is RC2. And as you are using the two inputs, you are using two inputs. This R1, this is V1. And here also you are using two inputs. It is having the V2, R2. And you are having the two outputs, V01 and V02. Because as I said, dual input, balanced output. It means you are having two inputs, V1 and V2, and it is having two outputs, V01 and V02. And this is about the simple diagram of your dual input, balanced output, differential amplifier. As I said, you are using the two transistors, they are the same type, and both the emitters are joined together and given the, you can connect in RE, the common resistor to the RE, and you are using to measure the output voltage across Q1, that is you are using RC1, to measure the output across Q2, you are using the RC2. RC1, RC2 are all your corrector resistances. R is nothing but emitter resistance. This is in brief about your dual input and balanced output differential amplifier. And here we go for the same. We can change the small area. Yes, we are going for the same dual input and unbalanced output. Only thing what you will change. I am not, otherwise I will try it once again to save the time. Only I will consider only one output. Or you can write it is having unbalanced, you are measuring only one output. Or actually another, by the symbol also you can mention. This is symbolically, it is having the two inputs V1 and V2, and it is having only one output, that is V0. It is called unbalanced. And in the balancer, like I said already, symbolically, in the balance having the V1 and V2, it is having the V01 and V0. So you can symbolically represent the dual input and unbalanced output differential amplifier. It means in your dual input you are having two inputs, no doubt, but unbalanced you are having only one output. Maybe here or here, you are having only one output. That is nothing but your dual input and unbalanced output differential amplifier. So for very simple. And now you go for the another one, that is called another type of differential amplifier. That is nothing but that is nothing but single input. That is nothing but single input and balanced output. It means here we are having only one input, but we are having two outputs. That is in brief about this type of differential amplifier. Or you can symbolically represent very simple. Symbolically, it is having only one input and is having the two outputs, V01 and V02. This is about symbolically. Or you can write the same diagram once again if you want. Means yes, it is having the yes, it is having you are seeing two transistors. You are having the two transistors. Their emitters are common. Or you can combine both the emitters and you can connect an resistor here. That is minus VEE. And here having you are using only the single input. That is V1, this is R1, and you are using an R1. You are using an R1, RC. Sorry, using an RC. You can connect here the positive resistance. This is RC1 and this is your RC2. And as we know, we are measuring here. This is V01 and this is V0. And here it is nearly to make it ground. Direct amplifier. It means it is called single input. You are applying only the input to the Q1. You are not applying input to the Q. Q2 is grounded. But balance output means you are arriving the two outputs, V01 and V02 arriving the outputs. This is the code in simple way of single input and balanced output differential amplifier. As I said, the both emitters are combined together, and we can, if you want to measure the output across collector using RC1, RC2, and always you are giving the input to the base for Q1 as well as the Q. This is about in simple way of single input and balanced output differential. Now we go for another one, and that is something that you are last. That is called your single input. The fourth one, the single input and unbalanced. Here, very simple. We are having only one input, one, and only the V1 and V2. This is in symbolically, or if you want to try to see in the diagram. Yes, we know already. It is having the common emitter, so RE, and you are connecting a negative VPE, and here if you want to, we are using a characterizer. We are also using a characterizer RC1 and RC2, and it is connected positive VCC because it is having only one input, applying only one input and one output. This is about the here we can make it the ground of this, and we will measure here the region. This is about in simple way of your single input and unbalanced output differential amplifier. You are having only, you are applying the input only in one side. That is called a single input, and because of you are applying only one input, you will get only one output. This is about in simple way of your single input and unbalanced output differential amplifier. And as I said, it is very easy to remember while drawing the figure. If I said orally, you will have some confusion, but if you draw the symbol, or you can write about this circuit diagram in symbolically, as I said, it is having the single input and single output. As I said already, V1 and V01. That is nothing but your single input, or on another side about if you want to write in simple way how to remember this once again by the symbolically. You can write symbolically and you can understand very easily. The first one is about what is first one? Two inputs, V1 and V2. Also two outputs. V01 and V02. We are not having confusion. At the same time, another type, no doubts, you are having two inputs, but you are having only one output, V1, V2. You are having only V01. That is nothing but is called dual input and balanced output. Here, dual input, unbalanced output. And another way, single input and balance output V01 and V02. So V1. And last one is single input and single V2. This is the different types of differential amplifier. We will go for the so important working principle of your construction and working principle of your dual input and balance output difference amplifier. So for the dual input and can write dual or can write balance output difference amplifier. So for the working principle of your dual input and balance output differential amplifier. And as I said here, you are applying the two inputs and also you get the outputs. Then how actually it works? What is the working principle of your dual input and balance output differential amplifier? We go on that. First you draw the D diagram, and as I said already, you have to draw the D diagram. You want to write a very big diagram. Very big diagram. And as I said here, it may be any type of application or mode. We can apply both the emitters are combined together. This is nothing but minus E or E. And here we are using an resistor. We are applying an positive VCC. We are applying an positive VCC. We are applying a positive VCC. And this is your RC1 and this is your RC2, and here we are applying them different inputs, and look here you are applying the two inputs. Here we will apply the two inputs. This is about the simple diagram of your Q1 and Q2. Look here, you are going further studying about the working principle of your dual input and dual output. You get the V01 here, also you get V02 here. V02. It means you are having two inputs and two outputs. And as we know already, in general, it is not possible to apply both the input simultaneously and you can measure the output simultaneously. That's why we can consider only the single input and what is the, if you apply the only considered Q1 or you apply only the input to the Q1 and you are not applying anything to the Q2. In the next time, if you apply the input of Q2 and you are not applying anything to the Q1, then you can understand very easily the working principle of your dual input and balance output differential amplifier. And after that, as we know about by using the superposition theorem, we can add both inputs. By using your superposition theorem, we can go for the, in the finally you want what is the effect of both the inputs if you apply by using superposition theorem, we will get the output. And in the first case, we consider the case 1. We can go for the case 1. Consider the, we can apply V in. Consider the V in. We are applying the, consider V1 and V2 is ground. Or you are applying input to the real. Or you can write, we are applying the case 1, we are applying applying input to the given, and it is grounded. And if you want, you can write another by the symbolically over here, or if you consider the first case, what is the effect of first case? First, what you have to do? Consider the applying V1 and make it V2 ground. This is connected to the ground. This is connected to the first case. We are only applying input to the Q1. We are not applying any input to the Q2. Then how it works? And basically, if you are using any amplifier, what is the condition? The input is forward bias, output is reverse bias. Now, how to make it input forward bias? That is by using R1 and RE, and by using VE, you can make the input as forward bias. And how to make it reverse bias for the output? That is RC1, RC2, VC, that makes the output as reverse bias. And here, as I said, your emitter is common for the both input as well, because the both emitters are connected together, and it means that both the emitters are connected together. That's why the emitter acts as a common for input as well as output. And look here, as I said here, you are applying only the input to the Q1, you are not applying input to the Q2. Then what happens? As we know, you are applying the input to the emitter base section. You are applying the input to the base, and as I said, the emitter is grounded. It means it acts as a C amplifier. The Q1 acts as a C amplifier. Why it acts as a C amplifier? Because emitter is common or grounded, and you are applying input to the base. It acts as the Q1 acts as a C amplifier. And as we know the property of C amplifier, because of the C amplifier in the output, in the RC1 you get the input and output in the 180 out of phase. What I am saying? We are applying input to the base of the Q1, and emitter is common. It means it acts as a C amplifier. In C amplifier, always input or output are the 180 out of phase. It means in the V01 will get the output. That output is 180 degree out of phase to the input. In the collector 1, you are measuring the output. In the collector 1, you are measuring the output. That output is 180 degree out of phase with the input signal. This is about the Q1. Then, what is the effect of Q2? Because in the Q2 you are not applying anything to the base is grounded. But whatever you are applying the input for the Q1, that also input will appear across this RE. It means because both emitters are common, that's why whatever you are applying the input to the Q1, that small part of the input is appear across the RE. What I am saying, you following? Actually, you are not applying any input to the Q1, but whatever you apply the input to the Q1, the some part of the input here they will drop across RE, they will drop across the emitter. It means this input acts for this voltage acts for input for the Q2. Whatever the voltage across RE, that voltage acts as the input for the Q2. It means in the Q2 we are applying input to the emitter. In the Q2 you are applying the input to the emitter, and you are done base is grounded. It means the Q2 acts as a CB amplifier. Q2 acts as a CB amplifier. So follow what I am saying. It means because you are applying input to the Q1 and you are applying to the base as an input, that's why it is called common emitter amplifier. And because of the common emitter amplifier property, you will get the input or output out of phase. It means in the collector 1 you will get the output. That output is input output in the 180 degree out of phase. It means you can say Q1 acts as C amplifier, and C amplifier the input or output are in the 180 degree out of phase. And this is about Q1. What about Q2? In the Q2, we are not applying any input to the base. Base is grounded, but as I said, both the emitters are connected together. It means whatever you are applying input for the Q1, that some part of the input is dropped across the RE. And this voltage, whatever the voltage dropped across RE, that acts as the input for the Q2. That acts as the input for the Q2, and especially you are applying the input to the emitter section, and base is grounded. It means your Q2 acts as a common base amplifier. And as you know the property of common base amplifier, in common base amplifier the input output are in the same phase. It means in the V02 we will get the output, that output is in the same phase. In the V02 the input output are in the same phase. But in the V01 we are having the input or output in the out of phase because of the Q1 acts as a C amplifier and Q2 acts as a common base amplifier. C amplifier and C amplifier. This is about the case 1. Applying one input to the V1 and V2 is grounded. We go for next case. In the next case, case 2. We go for the case 2. Very simple. Case 2. For the case 2, apply input to the V1. Now we apply input to the V2. And V1 is grounded. V1 is grounded. Now what you have to do? You can slightly change the input output. Now we can connect the Q1 to directly ground. But here you can apply the input to the Q2. This is R2. Now what happens? In the second case, you are considering only you are applying the input to the Q2, but you are not applying anything to the Q1. Q1 is grounded. The input Q1 is grounded. Only you are applying the input to the Q2. Then what is the effect of the difference amplifier? Same thing. As I said, consider the Q2. Because in the Q2 you are applying the input to the base. You are applying to the base, and as I said, emitter is common for input as well output. It is acts your Q2 acts as a C amplifier. Acts as a C amplifier. Why it acts C amplifier?